All right, hello everyone. Thank you so much for joining us tonight. My name's Sara. I am one of the events directors at ACM AI, and Kara is our other events director, and we will be moderating tonight's event. We are super excited to host Sara Hooker, VP of Research at Cohere and head of Cohere for AI Research Lab. Please give her a big round of applause for being here. Yes. So Cohere is a frontier AI research company founded by ex-Google researchers focused on building large language models, also known as LLMs, for enterprise. Sara leads a team of researchers and engineers at Cohere working on Aya, the state-of-the-art, massively multilingual LLM supporting over 101 languages, which is incredible. And that's more than double covered by any previous model. And they also work on Command R+, the first open source LLM to beat GPT-4. Previously, she was a research scientist at Google DeepMind, and she currently serves on the World Economic Forum Council on the future of AI and is an advisor / co-founder for Delta Analytics, which works with nonprofits and communities all over the world to build technical solutions and empower others to use data. Tonight, Sara will be giving us a talk about her recent work, followed by a prepared Q&A that we've taken some of the questions you've all asked, and then we'll have time for audience questions at the end. So without further ado, Sara.
Thank you so much. Wow, okay, I think this is on. Can everyone hear me?
That should be louder.
It should be maybe, oh, wow, okay, finding the right level. Okay, excellent. Well, thank you for the hearty applause. I hope expectations are not set too high. Let's see how we do by the end of the talk. And that was a very lovely introduction. Very complete, I will say. Yeah, I lead Cohere for AI, and I'm excited to chat today. It feels appropriate because we just launched a new Aya model today. But I'm also just happy to talk about different things we work on. So we work on a lot of different research, efficiency at scale, hardware-software interaction, safety, generalization, pre-training. So yeah, we'll talk about Aya today, but we can keep the questions and Q&A more freeform and kind of see how we do. Also, this is kind of fun. It's small enough where we can kind of throw out questions as we go, and I'll maybe throw a question or two at, and we can keep it a bit more I guess fun and less like me going through a bunch of slides. But Cohere for AI, so we're a fundamental research lab. We also do a lot of work building out essentially like open science research. As I mentioned, we do a lot of different topics, and we can talk about that afterwards. But it's one of the first intentionally hybrid labs. So we have industry research staff and industry-level compute resources, but we collaborate a lot across institutions. And most of our publications are actually cross-institutional. I'll briefly mention the Scholars Program if anyone is interested. It will open again later this year. John, I'll just point towards John. He's a current scholar in the program, but we bring together some of the best rising stars across the world, and they work with us for a year with a lot of compute. John has taken down production already once. They get to work on really interesting problems in frontier AI. So this was last year's, and this is this year's. So it may be of interest to some of you. A lot of my research has been on really this idea of how do we train multiple objectives? Like how do we have a model that's both efficient and multilingual and robust and trustworthy, and how do we balance those objectives? Aya is kind of this at an extreme. So Aya was this goal that we were going to look at how do we have good generalization, not just across one domain, but 101 domains. And so we'll talk about some of the interesting technical problems that happen, but just to give you a lay of the land, Aya is 3 models as of today, 513 million data points that we released, 3,000 independent researchers around the world, 56 language ambassadors, 119 countries, 204,000 original annotations, 101 languages, and this is probably a severe underestimate of how many Discord messages. So this was like a 14-month project. It was a really large-scale science project, and it involved this massive research ecosystem. And 101 languages, you know, it's kind of interesting because you lose sight of it after a while, and then you have to think like, okay, can I name more languages? And up to 101. And I think it's very easy. Maybe you get the first 10 really easy, and then the first 20, and those are probably languages around where you grew up, and like languages around your community. But then you get to 25, and then it gets really hard. And when you look at the list, it's kind of wild. Like it's actually super fascinating to think about like what we were trying to do. We were trying to bring really the same gains that have been done only in English to each of these languages, to things like not only loud, but Kurdish, but Latin, to things like Uzbek, and also representation across many different languages which previously hadn't been represented, particularly in Asia and Africa. These are like some of the continents that have really been represented outside of a few languages. So this was our goal. And today we released IA23, so it's very timely to talk about this, and I'll talk about some of the reasons at the end where we talked about IA23. I saw someone be like, that's John. Yeah, John is on this paper, he worked on this, so he's also a good person to ask during the question and answer, but this was a huge scale effort. We released an 8 billion and 35 billion parameter model, and if you're bored during this, you can try on Hugging Face while we do this talk, and then tell me what prompts you think are fun in your language. Just don't submit naughty prompts, because earlier today, I took a snapshot of some of the prompts that have been submitted, and some of them were naughty, and I shared it, and someone who speaks German was like, oh, this one's very naughty. So, I don't want to do that again. But yeah, we can, at the end, if you have good prompts that you tried, let me know, because I'm trying to add a few more languages, so we get to add example prompts. So today I will talk about instruction tuning under what I will describe as severe constraints. And this is a nice quote to start us off. The limits of my language mean the limits of my world. And what I mean by severe constraints, I mean just the sheer difficulty it is to represent a lot of these languages because of compounding challenges. And I'll name a few. But maybe I'll put it out here. So why is multilingual modeling so challenging? Who wants to go? Infinite dimensions? Okay, what do you mean by that?
Well, high dimensionality, basically. You have so many vectors to worry about.
Yeah, you have a much larger coverage space that you want your model to represent. So that is true, and typically the way we get around that is by scaling, so that is also true. Like typically more higher capacity models gives you more representational capacity, so that's good, yeah. So more types of, I guess, representations that you want the model to learn. What else? Oh, wow, very bad. That's interesting. Normally that's who I have to prod to get to answer. Okay, excellent. So we have 2 questions there. So Maxime, why don't you go first, and then we'll go the row after. Yeah, what were you going to say?
Maybe data set size? Like maybe
Yeah.
there's less data sets and like...
Yeah, massive data imbalance. Yeah, we're in a type of machine learning problem where we don't have balance at all for the categories we want to represent, and this is typically where our models tend to do really poorly because we have global updates, we do empirical risk minimization. This is where all our tools struggle the most. Yeah, go ahead to the gentleman. Yep, go for it.
I would assume that tokenization is also an issue, kind of how some characters in some languages could represent different things in other languages.
Yes, excellent point. So particularly non-Latin based scripts. So some of our most famous tokenizers like BEP, they're all designed for Latin based scripts, and they're very good at that. But with non-Latin based scripts, and that's basically Chinese, Japanese, Hindi, these are all languages which really struggle to be represented. And yeah, we'll talk a little bit about that. Nice. Over here, there was someone, a hand up. Oh, excellent, over here.
I guess having like when you have a concept representing languages, making sure they are represented the same internally, but at the same time having enough uniqueness to each token that the model still knows as each language.
Yeah, that's a really interesting. Okay, what do you mean by that?
So like, for example, if I were to, give it a prompt in English, like give it the same from Chinese. I would hope that it would output a similar thing, but using data sets and also how these things are represented in society.
Yeah, that's very interesting. So I'll say this again, just for people on Zoom. This is very interesting. The idea that I think you're talking about is consistency in response, which is very interesting because it's actually, so I think of this kind of like the same dilemma as hallucinations. Like hallucinations is a flip side of creativity. With your problem, sometimes we want absolute consistency, like across all languages. Like we don't want the response to be different to the question of, what is the capital of Costa Rica if it's asked in one question versus another. But in another sense, we want very localized in different languages. So for example, we ran into this a lot in Aya with, for Korean, what should we speak? What should be the voice of the algorithm? Should it be honorific or should it be more casual? And so there's very interesting nuances. The reason I say this is kind of like hallucinations. The difficulty people often talk about with hallucinations is that they want to eliminate hallucinations. But hallucinations are bad when they don't map to our factual reality. But if it's something fun, like creativity, these are all facets of a sparsely populated area of the decision boundary, we want it. So when you typically clamp down on hallucinations, you also clamp down on creativity. And here, one of the biggest issues, because I agree with you, it's a very interesting, desirable property, is when you try to ensure consistency, you also typically default to the majority data set consistency. So it tends to be infused with like whatever values are in your majority. So it's really interesting. Yeah, that was a great answer. That hasn't come up before. Yeah, okay. Anything else? Go for it.
This is sort of related to the same point of like building representations of data in different languages that like could conform to like whatever the same cultural values are.
Yeah.
For instance, like it begs the question of like what should be the correct cultural values to support. Like,
Yeah.
do we want it to be consistent across like every language, like everyone, like all languages would respond to things maybe in Western cultural background, maybe isn't the best thing, right? But do we want to conform to like whatever the culture of whatever the language is, and that might have some implications.
Yeah, we're doing a project about this right now, which is quite fun. If you look at MMLU, which is like the widely used benchmark across all these models, it's like based on US-based exams, so it's like US law, US accounting. So we're basically like penalizing models that don't know US accounting. It's kind of wild. Yeah, go for it. And then maybe, yeah, go for it. One more.
There might be some sort of issue with like the grammar and subject-verb order.
Yep. Yep.
It could be an issue where I'm trying to fine-tune something and it always goes in one direction.
Oh, that's fascinating. I hadn't thought of it as a, a masked objective problem, but that is true. So for example, I often think of this in terms of gendered versus non-gendered languages, but you're right, there's also positioning of verbs, like where the verb is, where certain grammars are. It's like very interesting to think about. Yeah, okay, that was a good one to kind of kick us off. So I think actually there was some very fun ones that were said today. Some of the ones that were mentioned, which are very clear culprits, like things like data scarcity. So we'll talk about this. There's 7,000 languages in the world, and about 400 of them have like more than 1 million speakers. So this is like a classic ZIF distribution. So you have a very small fraction of languages which have a ton of speakers, and then you have a sharp cliff. And what's interesting is that it's not just the amount of speakers, it's that even within that, there's some languages that have received more attention. My mom speaks Gaelic, she's Irish, and Irish is definitely blessed, because even for its number of speakers, it's received a lot of attention. So Irish, despite only having 0.2 million speakers, has about 5,000 papers per speaker. But then you see something like Hausa, which has 70 million speakers and has 1.5 papers per million speakers. So it's not just the lay of the land, it's also where there's resources put in research. And this also means that many were left out of progress. So when we started IA, so this was 15 months ago, this was the reality of coverage. So you had things like Bloom that covered 46 languages. You had MT5, which was just a pre-trained model, so no instruction fine-tuning, that covered 101. And then you had XGLM, which covered 30. So no massively multilingual models. But partly this is a reality of also where we get our data. So most of our data comes from the internet, and the internet kind of reflects the composition of early users. It's skewed towards its history, right? So we have things like English, which are much more overrepresented on the internet, despite it not matching the amount of like speakers in the real world. I think this is very interesting. Like 5% of the world speaks English at home, but 63% of the internet is in English. And under resourced data, so this is kind of getting to the second part, which is this kind of baffling statistic that 80% of languages just have no text. This is what makes audio research so interesting. So I think it's really interesting to think about joint modeling and how do you use audio to augment your representation for some of these languages. But the second issue is not just data scarcity. I don't think this quite came up during the kind of suggestions, but data quality is dismal. So for example, this is a great paper by Julia, who is a research scientist in our lab, and it's showing that out of popularly used data sets, some of these data sets are automatically aligned, like sentences from one language to another, and 50%, over 50% are incorrect. So this is just shows that it's not just an issue of data quantity, but quality. Or may be difficult to generalize from. I don't know if anyone knows this data set, JW300. It got taken down because of permissions issues, but it was one of the best translation data sets for low resource languages. It was from the Jehovah's Witnesses, and it turns out Jehovah's Witnesses are very good at translating into all these different languages. But it was tricky because this is a very religious text. So if you train on it, it's very difficult to generalize from. You get a lot of, language that is used in a religious text. And so this is another one of the dilemmas. Some of the most rich resources might be very domain specific. I would also argue this under-indexing is due to compute resources. So this is from a paper that is led by a REVA that we did, which is the low resource double blind. And so this shows that there's a co-occurrence. So both where you have a low resource languages, typically you also have high costs of compute and lack of access to compute. So this is a quote I like. So when you're not part of the conversation, it happens to you and not with you. There's important kind of side effects to not having robust multilingual models. One is it's very interesting. Performance on other languages is often double taxed. So you have both these sharp cliffs in performance, which is intuitive, but you also have issues with tokenization because it's not well represented by the embedding space. You end up having much higher cost and it's higher latency. So this is a very interesting example of it translating into way more inefficient use. And so this is a very nice paper by REVA again. But also the brittleness of multilingual undermines safety for all languages. So it's very easy to jailbreak a model if you choose another language. Try it or don't. No recommendation there, but typically that's because all red teaming is done in English and maybe a few other languages, and so you're finding parts of the data distribution which are quite brittle for these models. And so really it undermines safety for all users because you have these very interesting kind of sensitive low data areas of training. And we see also, going back to that excellent question of consistency, so we find that multilingual models present higher levels of inconsistency than in English, and so definitely one of the key objectives is you want consistent performance across your languages. And I think this is interesting as like a setup for what we're going to talk about. Like, why do we care about this? And really our goal here and with the AYA project was to unlock state of art. So we wanted to improve upon the existing models and we wanted to think about like how can we, I'll talk about two problems really, which is one, we wanted to do it for 101 languages, and then today we released a model which was doing really depth-focused, bridging the gap in performance to 23. And it's an interesting time to work on this problem. Like, why might this be an opportune time to work on multilingual? So there's been several key breakthroughs to optimization over the last few years that have led to important gains for high resource languages. Like, what are those? Go for it.
I'm guessing one, I don't know if it's actually used in practice, but if you have really good neural machine interact with like big data somehow.
Okay. Yeah, interesting. I mean, you have to get to a very good language model first. And definitely there's been huge improvements in the quality. How do we get to that first really good model? Yeah, go ahead.
This would be a few years ago now, but the Horizon Transformer, that's like a...
Yes, precisely, nice, that's one. So we had an architecture breakthrough. We had transformers. What made transformers impactful for optimization?
GPT-3, I guess.
Oh, okay, nice, that's a good answer. It's like, well, transformers, GPT-3, it's a good way of answering. It's like, duh. Okay, but yeah, what about the architecture specifically? Nice, let's go here. Yeah, parallelism meant that it could scale better, so it's more scalable. Yep, what else?
Unlike some of the previous methods, the attention basis of that the target that wants to start to forget earlier.
So this was the GPT-3 moment, but it was also a transformer moment. I was at Google when a lot of that work was done. It's very interesting. A lot of it was this ability, because I don't know who of you have had the pleasure of like working with LSTMs or RNNs. So yeah, that chuckle said it all. Okay, so you escaped that. So the main difference is that LSTMs and RNNs were subject to a lot of unstable optimization. So gradient saturation, and couldn't remember, even if you got them trained, they were very bad at long context. So transformers, you could have a much longer context. Yeah, so I totally agree that's a big one. Yeah, transformers, yeah.
There's probably a capital case to be made, like we showed that it could work pretty well, and then an infinite amount of money started getting shoved into this pile to make it better.
Yeah, actually that's one of the bingo card, compute. So you could frame compute as a shovel of money. Yeah, that works. Yeah, go for it. Yep.
I guess the transformer architecture naturally lends itself to more semantically rich and living spaces.
That's true. Yeah. So I mean, that's part of like the end effect of performance, which is it got better. So yeah, we have architecture, we have compute. What else were the optimization changes that happened over the last few years? Go ahead. No, yeah, go ahead. Yes, excellent. Yep, we got big data. Yep, much bigger data, and ever bigger data. Yeah. What else? Go ahead. Oh, Atom's an interesting one. Atom existed before a few years ago. Actually, Atom's interesting because of how it's stuck around. It's very interesting for that reason. I remember there's still a whole flurry of research around optimizers because, of course, 2012 we had deep neural networks introduced, and then everyone was like, whoa, this works, backprop, and everyone then started doing optimization research, and what's fascinating is how long Atom has stuck with us. So it's very interesting. But yeah, you could say Atom is still a crucial ingredient. Yeah, what else? Anything that was particular? Go ahead. Tokenizers are surprisingly classic. Yeah, it's so interesting how little innovation we've done with tokenizers. Yeah, did someone want to say, yeah, go for it. Flash attention, yes, it added efficiency. Go ahead. You were going to say something else?
Oh, yeah, it just allows you to do less memory.
Yeah, maybe let's take one more up there and then we can see, yeah.
I'd say in addition, probably with the growth in retraining and fine-tuning for large models.
Yes, on the bingo card. Yeah, fine-tuning is huge, right? We didn't really used to do. And what's different about fine-tuning the way, because obviously fine-tuning has had longevity, but what's different about how we do it now? Anyone can weigh in on this one. Yeah. Okay, I see a few. I saw 1, 2, 3. Oh, and everyone's like, oh. Okay, who wants to answer? Maybe over there? Yeah, Transformers. Did you have your hand up?
I guess.
You can pass to someone else who had their hand up. You can tag a friend. It's like we can play Who Wants to Be a Millionaire right now. Yeah, go ahead.
Would it be techniques like LoRa and other more parameter efficient?
Actually, that's kind of interesting. That's definitely being super innovative from the efficiency side. Super interesting idea of you don't have to update all weights, but I wouldn't say that's what's been the breakthrough with fine tuning. Yeah, maybe we'll take one more here and then we'll just go for it. Yeah.
Maybe the idea of we start with this foundational model trained on kind of sort of self-supervised tasks, kind of starting with the than trying to do more downstream tasks of just training everything from scratch.
Yeah, and what's different about the structure of the data? So it's also changed to.
You don't have to label things.
You don't? Interesting. It's okay. Okay.
I think that people use ChatGPT and like.
Oh yeah, that's true. They use synthetic data, so that's true. Yeah.
So like good or bad responses.
Yeah. Okay, nice. Let's dig in. Let's get a bit further and then we can go. So I would say definitely scaling. So compute was mentioned, data was mentioned. So definitely transformers allowed for scalability. This was a good architecture change that was very, led to new scaling performance. Pre-training breakthroughs, I think a few people said that, like more data, which is very important, but also unsupervised objectives. We will talk a bit about that. And then I'll talk about the rest as we go through. So yeah, we're in this bigger is better race in the number of parameters. I'm very grumpy about this. That's why I work on efficiency research. I think that we should have to justify why this is the most simple formula that we throw at a problem. But this is the state of the world, so we throw a lot of computer problems. I am proud that today we released an IA8B that's super performant and that's much better suited to like everyday researchers to use. But I think in the short term there'll be still some people doing a lot more compute, and we're going to get better, smaller and smaller models. And this characterizes all tasks. It also characterizes both model and data set sizes. But we also got pre-training. So I think there were two things about this. So everyone was very down on pre-training as a concept. People had tried it, it didn't work. They tried it at small scale. That typically was the issue. So when it scaled up to Common Crawl, it was big enough that it worked. And what's interesting is that the person who started Common Crawl, he actually lives in LA. He started Common Crawl as like, really because he left Google and missed big data. And for years, no one used Common Crawl. Like no one, it just sat there on the internet. And now he's like, I'm just being sued left, right, and center. Like everyone's using it. Everyone's asking what's in Common Crawl. But it's kind of fascinating. Like he really had, there was no idea of using data at that scale. And so it's really interesting. That turned out to be key, as well as with the objective. But also, we changed some multitask fine-tuning. This is actually non-trivial. I think we take it kind of for granted now, but before we used to kind of have a model for everything. So you used to have your sentiment analysis model, you used to have your topic classification model, and all these would be separate. Like if you go to the early days of Kaggle, it's like predict Titanic, whatever, like one single task. And this was really a shift towards universal models. Like you're training on all tasks at the same time, and you're training a model to be more general. And it's a big deal because it changes the framework of what we expect of performance, but it also adds really interesting questions around like how do we measure performance? Because when you change to multitask fine-tuning and your goal now is to cover as many parts of the data distribution as you can, it's very interesting. Like it means that how do you evaluate? This is like a really open question. And what's interesting is that these two ingredients, so having a multitask and having instruction fine-tuned, really raise this question of like, how do you create a good zero-shot ability? So this is me talking to command and I'm saying, tell me a story about a wizard fish that goes to boarding school underwater. This goes back to the hallucination, because like we like this type of generation, even though if this was, because it's creative. And so it's very interesting. If we clamp too much down on hallucinations, we lose this. But it tells me a story. It's like a wizard in his own right, so wise. It kind of goes on about this fish. But that's very interesting because there's probably very few examples in the training data of like a fish who went to boarding school. So this is a good example of like just performing well on very sparsely populated areas of the training set. And you know, we can argue about what's zero shot and what's not. I think, to be honest, that notion is becoming a bit more strained now. I think the more you know about how little we know about the training data, it's very likely many combinations have been seen. Like, for example, for a long time people would say, oh, multilingual is a zero shot. This is so surprising it does so well. But I think a lot of it is just data that's snuck into pre-training that the model learned. But I will say that the concept of zero shot is still very interesting. Where does the model perform well? And so for this, it turns out two attributes are being very important. One is like preference training in general, so integrating human feedback about preferences. That's what John's working on during his Scholars program, as well as instruction tuning. So how do we have these, when I said how is it structured, it's not just fine tuning, it's that we fine tune on these instructions, and that kind of confers this instruction following ability. That turned out to be really key for getting styles of interaction that people like. It was also the beginning of the break between academic benchmarks and what people actually want from these models, because all academic benchmarks are super dry. They're like, are these two sentences saying the same thing? And it's like, yes, no. And as soon as instruction fine-tuning kind of imparted with these models an ability to follow instructions and generate longer completions, it turns out that these two are kind of in tension, and we'll talk about that a bit later. So what's instruction tuning? So it's just this idea that you frame everything as if it's a question and an answer, and so you're really teaching the model to cue on to whatever you say at inference time, and then you'll generate a response. And this combination, so training on all tasks at once, and this instruction style led to these steady gains. But what's critical is that this only works at a certain size. And so this is really interesting, right? It kind of feeds into our painfully simple formula that we need to get rid of why people want bigger sizes. I think we're getting, what this is really saying is that we just don't know how to optimize at smaller sizes, and I think we're getting better. We're learning ways that we can distill behavior. We're learning ways in which we can do data selection to do the same at smaller sizes. But zero-shot performance is particularly helpful for data limited regimes, of which multilingual is one. So all these developments that have happened over the last few years made this super timely to tackle multilingual, because zero-shot instruction fine-tuning doesn't need much data. Preference training needs even less. All these things are super well positioned to help with multilingual. This was our goal. So there's also research which just shows that multilingual had multitask learning benefits multilingual. There's good cross-lingual transfer. So all to say, that was the starting point. We knew that there were very promising results, and we felt like it was very timely. I'm going to briefly give the top line, and then I'm just going to talk about 3 problems that I thought were really interesting that we dealt with, and then we can open up for questions. So I think it's more fun if we spend more of the time on questions. I love how you're getting your questions ready. Not quite. No, the talk is probably another 20 minutes, but yeah. So because you're like, oh, I got to get my questions ready. Not quite, but So we had 3,000 collaborators building this data set. And this spanned 119 countries, so it was super massive. And it was the 14-month movement. I call it a movement because it was so global and it involved so many researchers, and it resulted in both the model and the data set. So the IA model and the IA data set. Our goal was, as kind of was mentioned in the lovely introduction, was to really expand multilingual coverage. So we wanted to double the number of models, and we wanted to beat the existing baselines. I think this is very nice for a research project because you kind of set out, kind of explicitly what your goal is. And we wanted to try any combination of strategies that kind of did better. And the top line kind of takeaways for the data set is that we released a lot of data. So 65 languages, 115 languages for the collection, 101 languages for the evaluation. This is all data that we released. It's huge. It combines human annotations, manual curations, quality check, translation. It's very big. For reference point, Alpaca, which many of you probably know is only 53,000 or 52,000 data instances. IA collection is 513 million. It's massive, and we cover 101 languages. So it's really the most extensive collection to date, and most people use it. What we found since we released it is they use it for their language. So they want to create a model that's monolingual, only serving their language, but then they use all the data that's there for that. We had a data contributions of instruction fine-tuned. And what was interesting was that we had very skewed contributors. So we had researchers all over the world. It was super fascinating who participated. We had typically the most contributions came from the most underrepresented languages. even within Europe, which is low, like it would come from like Irish or come from Basque, like very low represented. So I think people feel most connected to like wanting to give to an open science initiative when they feel like their language is not represented by technology. And then we also found it really important to have a UI, to have a leaderboard, to connect with the collaborators all around the world. What we found was that we wanted to reward quality. So actually the IAM annotations ended up being much longer, and they were perceived as much better. So we kind of plotted, we had this review system where they were automatically reviewed by someone else who spoke the language. And we find that it kind of suppressed the quality of previous data sets. But let me talk about the model, because some of the questions that are interesting to talk about relate to the model. So it's massively multilingual, it's instruction following, and it's got a diverse data mix. The first question that we had to tackle was, how do we improve data quality? So large-scale data sets are typically an unknown, so they're massive, they're crawled from the internet, data quality is low, manual inspection is not possible, and it's typically like too big to audit. Instruction fine-tuning data sets are typically smaller, but they're increasingly like a combination of many data sets. So they're like packaged and repackaged. Like you may have seen this if you've downloaded some of these data sets. And what's interesting is that the data provenance is often unknown. This is a paper led by Shane. And so data pruning and data weighting is an interesting direction. So how do we identify what data points are highest quality and most salient for the model? This was work led by Max last year in our lab, which showed that really you can eliminate a lot of data and you can preserve quality. So as long as you're eliminating the worst of the data, you can actually have less data and achieve the same performance and more efficient training time. So we showed that you just retain 30% of the data and same performance. And this was at a pre-training level. So this is like the most intense scale. This is also another paper for those interested in this topic. This was done by Miriam, and it's looking at how to prioritize kind of what you show to annotators, like what is important for feedback. But there's really a few questions when it comes to instruction fine-tuning. So it's not just data quality, it's data diversity. It's like, how many different templates do you have that are getting at the same thing? So what we learned from Aya is that, honestly, current open source data sets are not good. They're pretty rubbish quality, and they have extremely low prompt diversity. And we ended up having to both increase the amount of data as well as throw a lot of it out. So we collected feedback from native speakers, and we saw what data sets the quality of each. And we would find these extremely short completions, like basically one word. And to generate long completions, you can't train on these type of data sets. It's just going to result in very curt completions. And what we also found was that these completions, we wanted to create a fully permissive model, and so we had to stick to the licensing. And the most permissive licensed data sets are also the worst, unfortunately. And so what we did was we looked at all the data, and we found that what was happening was a lot of these data sets, particularly for multilingual, are created by templates, which means you take a single prompt format or structure and you apply it to an entire data set. And what's interesting is that we had to aggressively prune these data sets. So we manually pruned, so we basically got rid of 50% of prompt templates from 47 data sets, and we removed 44% in non-English. So we were both increasing the data as well as removing it. And we removed prompts with very similar answers, so very low prompt diversity, very little length. And what we did then was we also decided we're going to be super strategic and be open-minded about what we include. So we're going to have human annotations, we're going to have templates, we're going to play with translation. I think that was one of the suggestions earlier, you just translate. So we did that too. And we also did synthetic data. So we did such a vast array, because the idea was, let's see if we can find a good mix, and how do we weight it? And to the point, this is a nice kind of full circle moment, is translation a viable augmentation strategy? So we experimented with different mixes. So we were trying to balance multilinguality and downstream performance. Each of these ablations is actually quite expensive. So we tried a few variants because we're doing so much at scale. And we were looking at like, how do we balance these different things, like template, human annotation, translation. And we have these 3 variants, like human annotation heavy, translation heavy, template heavy. We found that it's interesting. To evaluate, we had to build our evaluations because there was so little multilingual with the coverage for 101. And so we did unseen task, in distribution task, human annotation. So we had compensated human evaluators to like have standardized, and then safety toxicity. But what we found was that on both unseen and discriminative, translation benefits the most. So translation is very viable as a protocol. It helps, particularly for the most low resource language. But we found that each data source contributed. So actually having a mix is very important. It's kind of like ensembling, like you end up with a very good profile of performance. And what we find for the final IO model, we observed the largest improvements in middle resource and low resource. So kind of one of the biggest gains there was an understanding that we need to balance our mix, and we can have these gains across all languages if we combine these strategies. I want to bring this up because I think this is still very relevant. So is there tension between performance on discriminative tasks and open-ended tasks? What do people think? And what do I mean by discriminative tasks? Go ahead.
Like a very discrete classification?
Yes, precisely. Yeah. So is there a tension between very discrete classification where it's either right or wrong answer, you have a metric like accuracy, and open-ended tasks? What do I mean by open-ended tasks? Oh, okay. Let's see over here. Yep. So you may have many different ways of rewriting correctly. Like if I asked that story about, the fish underwater at boarding school, there might have been multiple answers that I found good. So it's less clearly precise answer. Yep. So is there tension between that? Oh, wow, very excellent, very eager. Yeah, go for it.
I think so.
Yeah. Oh, do say more.
Well, I imagine that, I imagine that the evaluation metrics, they seem, as a human, to be different, like, intuitively. The way that we discriminate between two different things versus evaluating the quality of something more qualitatively.
Yeah, okay, that's definitely true. So the metrics differ. Yeah, what else? Let's see over here, excellent.
I feel like there are 2 completely types of tasks, so I don't know why they should be also compared at the same time.
Yes, yeah. Like if you have a model which does very well at discriminative tasks, yeah, it's very interesting. Should they be compared at the same time? Yeah, it poses a question of what are we trying to build models for? And we're kind of in this era where we want models to do everything, so we test them on everything. But you're raising this fundamental question of, what is your model for at the end of the day? Who are you trying to build it for? Yeah. Okay, so excellent. Yeah, oh, actually, behind, yeah, go for it.
So the abilities that you want for open-ended tasks, like creativity, that kind of conflict with the abilities you want.
Yes, yeah.
Hallucination versus accuracy.
Yeah, I mean, most clearly, actually, who else wants to add in here? I saw your hand, it was like, it was like that slow hand by the neck. Yeah, go for it.
Actually, I think there's 2 kind of tasks. Kind of the one level and then another level.
Okay.
I feel like open-ended tasks is more difficult than the discriminative. So for example, let's say the generative task. If I can do better on the generative task, actually I can also view the discriminative button, such as the classification, as one kind of generation.
Yeah.
To generate, tell me what this is, cat or dog, something like that.
Yeah, almost certainly. I do agree that the task at its most fundamental level is the same. However, I would say not all discriminative tasks are easy. MMLU is a good example of how our models really struggle with some specialized type of knowledge. But I will say also, going back to this point about this tension between open-ended and creative, one of the biggest issues is that when you are measuring a discriminative task, you don't want the model to keep generating, like, because everything counts against you. You're just looking for that one match for accuracy. And so there's actually just like a core, yeah, go for it. Did you want to say something else? Sorry. Yeah, that's fair. And you know, that maybe gets at this point here, which is that the way that we benchmark currently is that we have like consistent prompts that we use across all models in the same way. That's what we think of as fair benchmarking. But if you think about it, like, you know, if you know you're using a model, think about it in the real world, like how it's being used in systems or in businesses. It's not like someone's just going to take a model and use that benchmark prompt the same way. And so there's ways to condition the behavior of a model. Right now we rely a lot on prompting, but it's kind of a hack. I think prompting in general is a bit of a hack for a lack of controllability of models. But yeah, you can use prompting to condition it. That's very true. Over here, yeah.
Yeah, well, I agree a lot with that. That like the best way to get good results is through either zero shot. You can get RLHF to force it to do chain of thought. Like I think some of the GPT-4 models kind of implicitly do chain of thought at the start of responses now. But that could affect benchmarking performance because, like you said, if you're just searching for a keyword, that's kind of a disaster. And I also think, particularly with benchmarks, there's a problem where benchmarks created after the proliferation of ChatGPT have an internal bias for how OpenAI models respond correctly, like the things that they really like to respond to, because researchers are used to playing with ChatGPT, so they write prompts in a way that are compatible with how ChatGPT thinks.
Yeah, there's some interesting things to unpack there. I think about this often with the open LLM chatbot arena, which is that people have been using the chatbot arena for a long time. They have their favorite prompt that they want to use to compare, and it's maybe very different from real-world use cases of models. So I totally agree. Yeah, how are we doing for time? It's time for questions, right? So I'm going to zip along. Okay, perfect. Yeah, so and then we can open up and we can get really into all these grumpy topics. Yeah. So we did observe attention, like just out of the box. I think there's some very important points here that, you know, maybe you end up moving away from a universal model and you end up, you know, if you know you're just going to do discriminative tasks all day long, you end up conditioning a model for discriminative tasks. If you're doing open-ended, I think it's interesting because we've been in this universal model era, we kind of treat it as if we need the model to do everything. And I think now there's a very interesting question of like, how do we just have cheap adaptability of models to like our actual end use case? So that's a separate topic that's really interesting to think about. But just out of the box, there is attention. So when you get better at generative and longer completions, you do worse at discriminative. And it's often because academic benchmarks require these really short completions. So they're not representative of how humans want to engage with the model. And it's, IA, for example, the main gain was like in this much more fluid, longer completions. And so we found that academic benchmarks didn't capture the gap. Like we would see, we beat MT0, we beat Bloom-Z, but like we saw small lifts in discriminative, and then we saw just massive lifts in generative. So it was really interesting. Like win rate comparisons really told the story of how much more like these models, like the step forward for all these languages. And that was both in human evaluation as well as, because we had human annotators kind of confirm. By the way, that's another area where the standard, like especially with publishing, and we were submitting this to a conference, is to use GPT-4 as an LLM as a judge, which when you think about it is kind of nuts, because you're like, what are we really optimizing for? That it kind of ends up with the same style as GPT-4. So yeah, so we do human annotations and we do GPT-4, and it's really interesting to think about. So parting thoughts, so evaluation requires, you know, just as much, we had to build evaluation as we went, and we open source this evaluation suite. But to end, I'm also going to talk about the role of capacity, and that was really IA 23. So IA 101, so for 101 languages, we were pretty limited in what base model we could choose. Why? Why is that? Like, why did we use MT5, a model from 2019? Why did we do that? That's kind of wild that we chose that as the base model. It's a very good, by the way, these are all excellent researchers, many were my colleagues, but just thinking about how much has happened since 2019, why do we do that? Yeah, go for it.
Tokenizing compatibility for lots of languages?
Yeah, the tokenizer for MT5 is actually not necessarily any better than any other languages. Actually, it's kind of weird, it excludes code. So it's very interesting, like the Bloomstein model benefited from having code when it did multilingual. We couldn't even try that hypothesis because it just like doesn't tokenize code. Yeah, but what else? Why would we use this model? That's another reason. Like, why do we use something that can't even tokenize code? Yeah, go ahead, at the back, yeah.
Some pre-training on multiple languages.
Yes, exactly. So we were constrained by the need that all our languages were seen in pre-training, and we had 101. And there were no models that covered 101 in pre-training. And why did that matter? Like, why did we have to have it in pre-training? Go for it. Yeah, because we're dismal at adapting pre-trained models if it's not seen during pre-training. It's really hard. You have to do continued pre-training. You need a lot of data. Like, it's really hard to, the main issue is the embedding space. At that point is, like, it's very hard to shift the embedding space. People try and, there is a lot of work on it, but like, people try and kind of hack it. They add new embedding, they initialize, they double, so you have to add a lot of weights, and it's very difficult. This is one of the core problems, if anyone's interested in it. I'm very interested in this problem. I want to kick off a few projects around it. But yeah, what else? And I may have given it away by like flashing the slide, but yeah, if someone was quick enough to read the next slide, then they get the point. Yeah, go for it.
I guess the fact that there is such a sparsity of good data for these languages to begin with.
Yeah, but we did do a lot of work on that. We had 53 million, so that was pretty good. It was, I will say this, in the spirit of getting us to pizza and questions, I will say this, the biggest model in the family was 13 billion parameters. And why is that an issue? Go ahead.
It's just kind of small today. Like today we expect
Yes, that, but also there's something called the curse of multilinguality, which is that the more domains you try and cover, the bigger your model has to be to not sacrifice performance on any one language. Because you're essentially like multiplying the number of worlds that you want to represent by like 101. So 13 billion for 101 languages was crazy small. It's kind of like using a 430 million model just for English and like being like, cool, let's go, state of art. Like, it was just really throttling performance. And so with IA 23, we were really trying to understand this tension. We're like, we've studied breadth, and like we've had these really important gains for all these languages, but let's try and take 23 to the status of a first-class citizen language. And right now, only English and Chinese are treated like first-class citizen languages. Like everything else is pretty much like second, third-tier citizen. And so this is the paper that John was on that we released today, and this is IA 23. And what we found was that combining this much more powerful base, so kind of like fast forwarding progress, because the model we used before was released in 2019, this time we used a much more powerful base, released this year, Command R, and we found large gains over IA 101, but also over these other open weights models, like Gemma, like Mistral, like Mixtral, so it was the best in class AB that we released today, and it was a combination. We did do a lot of very interesting optimization techniques. We also did a lot of work on the data itself for these 23 languages, but a lot of it is that to really represent languages, you need depth, and so you need capacity, or you need to be very clever about how you use capacity. And so this is a very interesting step forward, and I think this is a nice moment to stop. So yeah, let us know what you think about Aya, but also maybe we open up for questions. Happy to stop there. Thank you. Thank you.
This is always fun. So thank you so much for the talk. So we're going to get into audience Q&A, and we had some prepared questions, but we're going to keep them to a minimum so that you guys can ask your questions. But from ACM AI, we just also wanted to know a little bit more about you. What got you into AI? Were you always into technology? Was this something you always wanted to do, or?
Yeah, I was not. Like, I was always very curious about problems in the world. My parents met in Sudan. My mom is Irish and my dad is English, and I grew up in Africa, so I grew up in Mozambique. I don't know if anyone here has been, likely not. But until I was 19, I got a scholarship to the US, to come to the US, but I actually was really obsessed by economics, because I feel like that was the most technical person I saw there. Like, there was an economist for the World Bank, and that was kind of my dream. It was like to be an economist for the World Bank. But to be honest, when I got to the US and you discover that there's more powerful tools than linear models, no shade for economists, I still have a fun spot, but it was kind of like, I was like, okay, this is super cool, because for me it's always been about problems and having the most powerful set of tools to work on problems. So my path has been probably interesting because it's both academia and industry. Like, I was at a startup called Udemy, some of you may know. I was there fairly early on before it IPO'd. Now it's fairly big. And then I was at Brain. And so I think for me it's always been about what problems are interesting. I would also suggest, don't be modality specific. Like, over the course of my career, I've done computer vision, NLP. Now, the pace of how the field changes is too fast to be very dogmatic about your toolkit. Like, it's much more interesting to choose problems rather than oh, I only do this using language models, or I only do this using that, because we're already in the multimodal phase. It's very interesting. Yeah, maybe that gets a bit.
Yeah, that's great. Our next question comes from something that you've spoken about, which is about how researchers in AI are so focused on fitting into the room that they forget that they can actually shape the room.
Oh my God, these questions are so good. Like, what? This is very impressive.
Going off of that, what responsibilities do you think researchers in AI have for making research spaces more inclusive?
Yeah, I mean, I think we still do a pretty dismal job. I mean, it's interesting. I think that we talk a lot about some types of inclusion, but I think about geographic inclusion a lot. Like, just visa issues, just the lack of ability to have talent. Like, rooms like this are super rare. Like, how many rooms do you think around the world are meeting like this at, what time is it? I mean, this is so impressive, but it's probably, you can count it on two hands, right? Like, the amount of computer scientists that can meet like this, and that's super rare. So I think about that a lot. I also think about, in some ways, that it's still wide open to change. Like, our field is very young. It's kind of fascinating if you think modern computer science started in the 1950s. And so I'm very optimistic that if we change the ways of collaboration, but I think it has to be, the incentive structure has to change. I think about this a lot because we work with a lot of collaborators across the world, and it's not enough to have some organizations doing it. So I think a lot about that. I think there should be the same way there's a Tested Time award at conferences, I think there should be award every year for the paper which broadens collaborations the most. So things like that. We have to have center stage examples of things that are working. But yeah, so that is a topic I'm happy to talk about after this if there's questions. Yeah. But these are amazing questions. Wow, this is very impressive.
Thank you. So we are gonna go to some audience Q&A. So we can help you moderate this, but also if anybody just wants to raise their hand, and you can just go ahead and call them.
I can repeat it for Zoom.
Perfect.
Okay, yeah, go ahead. I think you were first with your hand up.
I guess you were just talking about it a little bit, but I'm pretty interested in learning a little bit more about the human side of this project, about what is it like just managing so many different organizations who are interested, have a vested interest in this project, right? 101 different languages. go.
Yeah.
I'm just like interested in hearing like the human side of it.
Yeah, it was absolute chaos. Like, it was wild. Like, first of all, I don't think when we set out, we quite understood what we were taking out. Like, it's very difficult to build data as you build a model. And like, that was nuts. I don't know why we decided to do that. And then secondly, we had, you're right, we had totally people coming to it for all different reasons. We had, honestly, a super robust community in Somalia who contributed just insane amounts of data and then dropped off the face of the earth. Like, we wanted to thank them. It was just crazy. I don't know, like John knows Madeline, but Madeline was like trying to reach out. She's like, oh, can I send videos to thank people? And yeah, everyone's just gone. Yeah, it was very interesting. And then we had other groups, like we had Portuguese from Brazil, Portuguese from Portugal, and sometimes there you would see these interesting dynamics where, because we only had one Portuguese, so we didn't have dialects in this part, because it was already formidable, like the tasks that we were doing, but because everything was grouped around Portuguese, you'd find the Portuguese from Brazil were correcting, redoing all the things that the Portuguese, and you'd see the Portuguese and Portugal get cross because the Brazilians outnumbered them. Just like, wow. So there was just stuff like that was so interesting. I mean, we did a few things. One is we had a very loose organization structure, so we tried to everyone could jump in at any one time to either review data or give data, but also if you were there and you wanted to be a language ambassador, then you wanted to run experiments, then you wanted to be on the paper, we kept it fluid because we were kind of like, my whole philosophy is like, hey, there should always be a way for people who are giving their all to find what they want out of a project, you know? And so, but we were also ruthless about throwing out lurkers. Because I think this is dynamic, particularly in research, where people just lurk on papers. And so, one of the things that I was like, this is such a fragile effort, and we're all in different institutions. And I was kind of like, the worst thing you can do to it is for people who are giving their all to feel like there's someone who's just lurking who's going to get the same. So actually, I tried something new this time, which was honesty. I was like, hey, maybe you should regroup on this in a few months. I think, it sounds like you're not able to give. But that turned out to be really, really powerful because it meant that we were in it. And it meant that everyone who was in it was like, we are going to do this. And that was pretty crazy. That, especially the bonds that were formed towards the end, when we hit state of art, when we were so clearly above all the other models, that was wild because everyone was super connected. There was no one who was like, oh, cool, I haven't been here for 6 months, but great, there's a paper. Do you know that person? Everyone knows that person, yeah. So I think that was very good for the dynamic. And I think that worked from the person side, as well as we were honest about not doing it all. People would come in and they'd be like, yeah, this language that is very underspoken, can you do this, can you add this? And we were already trying to just do 101 languages. So we're like, we'll do this can be built on. The other thing that we said we couldn't do was dialects. A lot of people want dialects, and I totally get it because it's so personal and it's so part of your culture. And that is language, but we just couldn't do it. So what we ended up doing was having people self-identify dialects so that future researchers can use that field to start figuring out how to use it. So we were just upfront as well about what we couldn't do. And we kind of did it that way. Nice, yeah. What else? Yeah, I think you had your hand up before.
As someone who's been in this space of AI for a really long time, is there any aspect of working in AI or AI in general that you kind of hate suck?
Oh, I have so many areas. I don't know. I feel like I have I don't know, prompting is an example. Like, I'm just like, why are we so obsessed with like, oh, the best way to prompt when it's such a hack? It's like, as soon as the model changes, all your favorite prompting techniques fail. So there's like examples like that, like of science areas that I'm like, we should be better than this. Like, we should form a formal treatment of like, better controllability. Like, we're kind of resorting to like probing, tea leaf reading the input space to like understand a model's decision boundary. So yeah, there's grumpy things like that from like a topic perspective. I could name others like benchmark saturation. I really just makes me, for example, like the notion of what a benchmark means these days has become so meaningless because of the way people, the notion of test set is totally like, you know, it's like rest in peace, like, you know, like that makes me grumpy. And like I proposed the other day, like, oh, let's just use a held out test set. I was talking to Hugging Face and I was like, hey, we should really do a held out test set. And Hugging Face is like, do you think anyone will use it? I'm like, geez, like, what does the world come to? Yeah, so, like, yes, they should use a held out test set. So there's things like that. So definitely, I think if you've lost that as a researcher, because research is hard, so you have to have some things that, like, you're just, like, annoyed at, that drive you, and you want to change about the field. Mechanistic interpretability, I'm happy to chat about. I think I know a paper recently came out, and I know there's probably a lot of people who are now like, I want to do mechanistic interpretability. Don't do it. It's a swamp. It looks shiny, but... yeah, but maybe I'll say, like, those are the topics. I think what I would love to change about the philosophy of research, it's very hard to change the research rubric. Like, we're trying to do it, like, partly why we're a hybrid lab is, like, we really want to change how research is done. But it's hard because to show that it works, you have to do the exact same. You have to kind of win the top tier conferences while doing it differently, which we're doing. I'm super proud of that. Dare I say ACL, all acceptances just recently. But I do think this is very important. Our field is quite conservative. Researchers who I know still, the first thing they want to look at is someone's H-index. And it's really like, yeah, I've been in rooms, at Google, in hiring committees where that's why a candidate doesn't make it. It's the H-index. It's said it's too low, this is not the criteria. And that's absurd. Like, there's just much more dimensions to research, and we have to think about this in terms of like the impact, the scholarship, the quality. So that's stuff I want to change, yeah. Yeah, go ahead, you had your hand up.
I wanted to ask, how do you feel about symbolic AI approaches like Lisp or
nice.
For example, and
Cool.
do you adapt any of that in your model and techniques?
Yeah, that's such a good question. Wow, that's super cool question. Yeah, symbolic AI approaches. So symbolic AI approaches are very good at like small search spaces. So for example, they were really good at chess. They were really good at, controlled checkers. By delegating, so I think what people often fail to recognize is that our model architectures are kind of like a very strong prior on the conditioning space, which is what a symbolic approach kind of is. It's just that symbolic approaches codify it much more explicitly as a set of rules. But if you think about it, the reasoning between symbolic approaches was to impart human domain knowledge, and that's why it was kind of like, oh, if it's this condition, then you do this. I think about that as in terms of architecture design a lot, because architectures are actually confining the search space pretty aggressively. They're saying, convolutional neural networks were what unlocked computer vision because patches were local, and they took advantage of the fact that images typically have local relationships and can be collapsed into symbols. So I think about that, but in terms of mechanically with a symbolic AI approaches, I don't think, is there any part of a deep neural network that is symbolic AI? I mean, to be fair, activation functions are kind of symbolic, right? Like if you have, if you have kind of a step function activation. Yeah, what else is symbolic about neural networks? Well, who wants to add in? I'm kind of curious.
Putting the activation functions directly in the chips recently.
Oh, interesting. Oh, just directly on hardware? Yeah. What else is symbolic about current neural networks? Go for it.
I feel like maybe the fact that there's like a softmax in the attention.
Well, softmax is not a symbolic. Well, I mean, it's a I mean, it's not a symbolic function. It's not a hard coded, but yeah, it's interesting. That's a fun question. Really good. Yeah, maybe we'll keep thinking about that. Yeah, go for it. Yeah.
Sort of, I'm really interested in your work on the hardware lottery, and I've been thinking about, like, I grew up playing a lot of video games, and
Oh, nice.
video.
I did too. I played a lot of
And when I would go to like graphics conferences with my uncle when I was in high school,
Oh, you played a lot of video games. Okay.
Jensen Huang would come and he would be like, our GPU is the best at ray tracing. And then like it just so sort of happened that because they were doing all of these work to make like rasterization and ray tracing better, that we sort of got to this absurd world now where everyone's trying to interpret some version of next token prediction into their UI that probably doesn't even need it. But like that's a different story. So I'm just curious, to what extent do you think video games sort of resulted in like this whole loop? Because I think like I can't say like if that industry didn't exist, if we would have GPUs that.
Yeah, I agree. I think that's what's so sad about the story is like it was so lucky that GPUs came along when they did. I mean, I really respect. Has anyone here heard about Schmidt-Huber? Okay, you're missing out on like a very interesting chapter. Is this still being recorded? Yeah, I guess this is still being recorded. Okay, let's go for it. Why not? Yeah, Schmidt-Huber is like the only, kind of committed researcher who went through both, the second AI winter, the 2000s without being recognized. Like Geoffrey Hinton, Yan, Joshua, they were all ultimately recognized, but for all four of those researchers, I mean, pretty brutal, right? You're pursuing an idea for decades that has no empirical support, and you have people who are constantly like not believing in your idea. And I think what's fascinating is it was very much GPUs. GPUs allowed for deeper networks. They allowed for the first empirical success of deep neural networks. Convolutional filters, to Jan LeCun's credit, also really allowed for much more efficient representation of images, the same way transformer did of text, but without GPUs, it wouldn't have been an empirical success. And the reason I bring up Schmidt-Huber is that he was never given a Turing, and he's kind of, he's the type of researcher, so it's an honor to be Schmidt-Huber, people still say that, is that Schmidt-Huber he has kind of this dream blog where he writes down a stream of ideas that over the decades, and if you ever actually publish something that's one of his dream ideas, he'll message you being like, why didn't you cite me? So it is called it's kind of like an honor in some ways, or Schmidt-Huber, but he'll also go up to the podium at conferences and he'll take the mic and he'll be like, actually, you should have cited my paper. And so you should know about Schmidt-Huber. He's very much part of the spirit and the history of deep neural networks. And what's interesting is that he actually never got the Turing. So he never got his, I think because he annoyed the rest of the Turing winners so much. There was fractions there. But that's what I will say is that, what's crazy, it was because of GPUs, but I think it's also now because of GPUs that we're not exploring anything else, right? Like we're just stuck with deep neural networks. And deep neural networks are by far not the future, right? I think they're global updates, so they have catastrophic forgetting. They don't adapt easily. Empirical risk minimization means it takes ages to learn rare features because we keep on using average to optimize. And so that means that if you have a rare feature in your batch, it's going to take you ages in training to start to learn it. And also, we show the same amount of data at the same amount of times. We have no adaptation over the course of training. We just press go, and then we come back. It's nuts. Like, there's so many things about deep neural networks that are not the future of like how we represent data. But it's getting harder and harder to stray. So, yeah, fun question. What else? Oh, nice. Okay, there's some excellent. Maybe over here, and then, yeah. we're working on that now. We're working on like geo-specialized models, because you're right, there's a lot of cross-lingual transfer, especially when there's linguistic similarities. So we're like working on how far you can take that. But in general, there are benefits from adding more languages. I actually think what we're now exploring is, because, for example, embedding spaces tend to like overfit so much to like the majority language. I think it's interesting to think. I actually think this is most interesting with non-Latin based scripts. I think it's really fascinating to think about, and there should be more work there. I'm seeing this a lot with like national bets on languages. So, for example, Chinese is a first-class citizen language as well, and there's been extremely good Chinese models that have been released, and there's probably even better models which are proprietary, and it's very interesting because both English and Chinese have had a lot of like optimization care paid to them, and so it's really interesting to think about like, can you do that for clusters of Asian languages, and what clusters? Because for example, Vietnamese is kind of fascinating because it's not very linguistically similar to other Asian languages, and so you have to kind of pick and choose like what you group, which is kind of interesting to think about. But yeah, great question. Yeah, what else? Okay, we have someone in the very back, and then I'll take the other one there. Yeah, go for it.
Thank you. My question is, with this research done, what are the future directions that you're thinking about taking this? And also, are you thinking about real-world applications?
Oh wow, well we released I-23 today. So I think I'm going to take a break. That's funny. Yeah, what are the future directions for IM? I mean, we have a lot of multilingual bets in our lab, so a lot of our research bets are currently on multilingual. But I would say I've always been a bit like a portfolio of research type person. Like there's multiple questions that I think are interesting at any one time. Like, you know, one is multilingual. I'm also really interested in pre-training dynamics. Like, you know, what's most conducive to the best pre-trained model? What do we know about what should happen with pre-training? Also, why is pre-training a stage? Like clearly there's a world where you can just train, right? Like it's kind of weird that we have 3 hacky steps that we're like pre-training, fine-tuning, preference training. Like that seems kind of odd to me. So I think things like that are interesting. But yeah, I think, you know, I would say, like, you know, my suggestion for researchers starting out, or for people who want to do research, your first project should be like mastery a single domain. Become the expert at that domain, because that's your calling card. That way you can go into a conference and be like, I know this, I know the literature, I've executed a project, I've gone through all the stages. There's so many weird parts to research. It's like the engineering. You should be strong into engineering. It's the results interpretation, it's the rigor, it's the writing. So I always say, go deep. But then I always say, the best researchers have a command of how their field connects to others. And like, as you go through it, you'll start to see more and more interesting connections. And yeah, I think that's kind of, yeah, they're both very important stages. Yep, okay, and then you've had your hand up a few times, go for it. And how are we doing for time?
I think we can do like a couple more questions.
Oh, perfect. Okay, nice. Yeah, go for it.
I had a question about what you said earlier about cross-lingual transfer being more easier across like similar languages. I was wondering if you could sort of quantify what that similarity was, whether it's like syntactic or whether it's like language relationship or like cultural similarity between them.
Yeah, there's very little research on this. So the research has been done has shown cross-lingual transfer matters. Typically, when you add more languages, you benefit the particularly low-resource languages, and typically you cannibalize from the most, you know, resource language. What's also being shown is that certain families tend to benefit more. So, like, let's say you pair French and Portuguese and Spanish, and then you throw in Russian. Not anything against Russian, but it's a different script. So, so that's why it's fun to think about here. So typically in that cross-lingual setting, the language which will benefit the least, although it will still benefit, is Russian. But let's say you then turn it around and you flip it, and it's like Russian, and maybe you have, give me some more languages, Ukrainian, pardon, what were you going to say? Oh, Swahili. Well, I didn't think you were going to go there. I thought you were going to go like geographically close to Russian. Okay, this is turning into a wild training run. Okay, so So then you have Russian and Swahili and maybe you have Ukrainian. There it's kind of like, who knows, right? Because we know from IED that all languages benefit from cross-lingual, but what you can say about what's actually transferring and what features are transferring, I think needs more work. And kind of our bet with geo-specialization and training is that models will get bigger gains if they're placed next to other languages which are similar. So yeah, great question. Yeah, go for it.
So you mentioned thoughts about architecture being like a prior built-in.
Yeah.
Have you thought about any architecture as a prior for like languages where you have some sort of general cognition thing with different head and tail encoders or different head and tail layers per language?
Oh yeah, there has been work on, I mean, adapters is kind of, I would argue, a version of this, and like adapters have been used for language adaptation. John actually put together a collab for the new IO23, dare I say, that uses adapters. What I would say is that, so the idea of modularity is super interesting. I actually think about this more in terms of mixture of experts. So mixture of experts are meant to give you modularity and specialization. In practice, that currently uses an efficiency hack. There's not much true specialization that happens with mixture of experts, but you get a lot of efficiency gain during training. I would love if we had more true specialization. How can we make that more modular? And part of that I think is going to be new techniques that are like this branch tray merge that came out, but modularity is very interesting as a concept because we clearly have it, in our neuroscience, there's certain modularities, there's certain parts of the brain that activate more for certain functions, and it's very interesting to think about it, how we impart it to models. Typically our main issue, why it's difficult, is that using global updates. Yeah, if you update all weights, it's really hard to confer specialization. And so things that try and avoid that are really interesting as a problem. Yeah, and then over there, okay, yeah, go for it, yep.
Yeah, I just want to ask, what do you think of the prevalence and really dominance of private industry AI research?
Yeah.
Any aspect really?
Yeah, I think it's very difficult for researchers in academia right now. I think that there's various issues. It's compute mainly. We're in a compute-heavy game. So the biggest divide I see is a gap in resources, which means that researchers in academia increasingly have to do things like evaluation or it's so interesting. I was on this panel and someone from industry was saying, oh, it's great because academics can do all their adversarial testing. And I'm like, what? Like this is, what if you're a researcher who doesn't want to do adversarial testing? I think, so this is the main divide. I think that's why we set ourselves up as a hybrid lab. We're an industry lab, right? Like we have compute resources where, we have full-time research staff. But partly why we set ourselves up as a hybrid lab is that we want to collaborate because there's so much talent in academia. And most of our releases are cross-institutional, and in return we do a lot of compute sharing. So a lot of our academic partners leverage our compute, and we give out compute grants as well. What do I think about the wider landscape? I think that there has to be more national policy around compute. Like the issue with our national compute policies is that a lot of it is in these compute centers that were designed for like biology workloads. And there's no like Slurm queue. And how is someone going to use it? Like you have to apply and then you have to and then, machine learning workloads, especially for research, are really interesting, right? Because they spike before conferences and everyone needs it at the same time. So that's not how traditional infrastructure is being set up. And so I think that universities have kind of taken their own hodgepodge approaches and for example, I was just talking to Jonathan Frankel. He decided, I think he's at Mosaic right now, he was going to go to Harvard, and they tempted him by saying, we're going to give a ton of GPUs and things like that. So there's some universities who are making big bets and just like solving it for themselves, but that doesn't really, that's kind of industry all over again, right? It's like some industry. So yeah, I think it has to be national policy. And that's starting to happen. The UK, for example, is doing their new compute planning right now. But I would say this, I think compute policy, no matter what's decided, has to also take into account that a lot of researchers outside of academia, the ones that are moving the fastest. Like we have independent research groups like Luth AI, even Cohere for AI. Like in our open science group, there's super talented researchers that aren't affiliated with the institution. So we also have to be more permissive for that. Yeah. Okay, go for it. Yeah. At the very back. Yeah.
You mentioned dialects in particular a couple of different times. I wanted to ask, what particular challenges do dialects pose in terms of data preparation and training?
Yeah, I mean, you have another long tail again, because let's say we had to try and balance. So a lot of the optimization work for multilingual is sampling strategies. How do you balance languages? That's why translation is not the best data, right? But at least it's balanced by definition, because you're translating one corpus into the same amount for all other languages. So you have skew with languages, but then you have skew again with dialects, so it throws your optimization through a loop. So I think that's one of the technical problems about it. Logistically, it's also hard because your annotator reviewer pool becomes much smaller again. Like, okay, not only do I need a person from a language that's not spoken by, like maybe it's spoken by 12 million people. Irish, we had our Irish language ambassador, that's spoken by less than 1 million people. And then if you added in dialects, because she was, Laura is fantastic, and she was saying like Cork Irish is different from Dublin Irish, but there was just no way. Like that's like, how are you going to get incentivized pools for both? So yeah, it's pretty tricky. Yeah, go ahead.
So for some languages like Spanish, which is like, I'm just thinking of Spanish in particular, that is spoken in so many countries and there's just so many dialects, do you think there might be approaches where maybe you favor some languages and train them for different dialects, or?
This is bringing back memories of the Portuguese. Yeah, I definitely think so I actually think there is room for dialects in optimization. It's more that in the first stage where like, even the status quo for languages is so, poor. But I will say this, like when people interact with an algorithm, their use case is their language. And that is dialect. And so if you have Spanish in Mexico, Spanish in Spain, those are very different dialects, like even the vocabulary, even the expectation. And so I think that is the next frontier for multilingual, is like adaptation. And it's how to do it efficiently, because our main hurdle with the IA 101 to IA 23 has been the need for a pre-trained base that has seen similar data. So for me, that's kind of absurd, right? Because then you depend on this massive investment in pre-training, and there's no going back. It's like what you chose at that time. Like our 23 list is really interesting, and it wasn't like, it's not like when we did the IA 23, we knew that would be our 23, because it was already pre-trained, and then we took it and we're like, cool, let's do IA with it. So I think this is one of the most interesting technical problems that we currently have to grapple with, is like, how do you efficiently adapt? And how do you adapt to different dialects, to different nuances? Yeah, go for it.
Yeah, I was going to ask a follow-up to that. If like the goal is to be able to use LLMs like all across the world, all like different languages, we spoke a little bit about efficiency as well, about how everything's kind of just bigger and increasing compute power. Do you think that's like sustainable, one? And two, like what are the different approaches? Like I just wouldn't think there's every single country could even have.
Yeah, I think right now with the current architectures we have, it's pretty, we have a very inefficient way of learning representation. So the curse of multidimensionality is really because we have to go big, because like we're doing all this, we're basically a frequency counter, right? Like we count the number of times the model has seen the data point, and that's what we learn. What I would say is that I think that there's a trend where that's getting better. Preference training is an example of this. You can align things with a lot less data. We've seen equally as many things with optimization as we've seen with like our base architecture over the last few years. Actually, it's very interesting. I just did a plot the other day of 7B performance on the leaderboards over time. So I don't know. I guess it's a bit, I'll do a quick caveat that, there may be an underlying variable that people are like forgot what a test set is, but we are seeing like performance go up really quickly at the same capacity. And so there's two dual bifurcations trends in compute. One is we're getting bigger and bigger, and we have to grapple with that. We also have to grapple with the fact that the biggest cost is not training, even though I think that's what people focus on. It's actually serving, because you have to host a model repeatedly. And it's actually also when the way that you're basically continuously hosting very big models. And so it's very interesting. People focus on training a lot, but serving is really, really, especially when you do fine tunings, when you're doing personalization, you just spin up a new model, unless you're doing it very clever ways using adapters. So yeah, but I agree. We have to grapple with what it means. Yeah, is it pizza time?
Yeah, I think we're out of time for questions.
Yes, I could sense it. I was like, okay, amazing. Thank you, everyone. This is really nice.
All right, thank you all for coming. Again, big thank you to Sara for spending her night here and for that wonderful talk. And quick shout out to all the ACM officers who made this event happen. And if you like this event, you should definitely follow us on Instagram and join our Discord. There should be a slide up there with QR codes. So if you don't follow us, do that ASAP. And we have pizza in the back, so if you're hungry, please take one slice at a time because it is limited, and then we can go from there. But yeah, again, thank you all for coming. Yeah, good night.